One last type of trig ratio problem we need to look at today is the one where they have basically given you one trig ratio and ask you to find another one. So in this case, what you're going to need to do is if they happen to give you a reciprocal ratio, for example, if they happen to give me a secant, like if they said secant of theta was 3/2, I would immediately say, well, which one goes with secant? Secant goes with cosine, and I'd get cosine of 2/3, and then I'd move on from there. Fortunately, on these problems, they haven't been quite that mean. That's kind of a upper level trick there. But regardless, we still, with a sine, we need to draw a right triangle. So here we go. Label the angle we're talking about, and then hypotenuse. Opposite is across from the angle, adjacent touches the angle. So hypotenuse, opposite, adjacent. There we go. And sine is always opposite over hypotenuse based on SOHCAHTOA. So it is opposite for hypotenuse 5. So that is labeled. Now I need to use Pythagorean Theorem to get this other side. So my adjacent is going to be 25 squared equals a squared plus 4 squared. You could have used x as well. Choice of variable doesn't matter much. You'll do a little bit of work. You'll do 25 minus 5 squared. I already squared it there. 5 squared minus 4 squared would be 9 is a squared. So it turns out in this case that adjacent side is 3. So if I'm looking for cosine, cosine is adjacent over hypotenuse, so cosine is 3/5. The truth is you can find any trig function you wanted, but in this case it wanted cosine, which is 3/5. Let's go ahead and do the next one. Switch colors to help everything stand out. We have a tangent, so I'm going to draw my triangle again. Label the angle I'm talking about. This is hypotenuse always across from the right angle, opposite adjacent. And my tangent is going to be always opposite over adjacent, according to SOHCAHTOA. So I can label this side as 15, and this side is 8. Now the next step I'm going to do is use Pythagorean Theorem again. So in this case I have 8 squared. I have both legs, so 8 squared plus 15 squared equals c squared. And after doing a little bit of work, I think you're going to find out that c squared is 289. So c is 17. So when I go for my sine function is opposite over hypotenuse. So sine in this case is 15/7. Once again, I could have found any trig function, but sine was 15/7. We'll switch colors one more time and work through one more example. This time they gave you tangent as 1. You're like, I don't even have a fraction. Well, you can always write it as a fraction by putting it over 1. So now when you set up your triangle, you have hypotenuse, opposite, adjacent. I usually set up my triangles the same way every time. Just keeps it simpler. The tangent is opposite over adjacent like it was last time. So opposite is 1, adjacent is 1. Hypotenuse, I would need to do Pythagorean Theorem. 1 squared plus 1 squared equals c squared. It's going to turn out in this case that c squared is 2, which means my hypotenuse is square root of 2. So now when I go to do cosine, my cosine is going to be adjacent over hypotenuse. So it's 1 over square root of 2. And we do need to rationalize. That means I'm going to multiply the top and bottom by square root of 2. On the bottom, square root of 2 times square root of 2 is equal to 2. On the top, 1 times the square root of 2 is square root of 2. So I end up with square root of 2 over 2 as my final answer for cosine. And the truth is, since opposite and adjacent were the same, sine would have turned out to be the same thing too. That's a special property of those isosceles right triangles. Please reach out to me via Zoom or email if you have any other questions. Hope this video helped a lot.